All right, we're going to be talking about I raised to the nth power, I raised to some sort of power. We've been talking all unit about the fact that I is equal to the square root of -1. You've also learned that I squared is equivalent to -1. We talked about that in an earlier video. Now what we're going to look at today is what happens whenever we have something I to a higher power, maybe I to the third. Well, what I want you to think about is how can we take I to the third and write it out as smaller pieces. So I to the third can be written out as I squared times I, because whenever we do this, you just add the exponents. So I squared times I, 2 plus 1 would give me the 3 that I needed. Well, simply by doing substitution here, we know that I squared is equivalent to -1. So this is the same thing as -1 times I. Well, that's just equivalent to -I. So I to the third is -I. And then we have I to the fourth power. Well, let's look at how we can break down I to the fourth. So go back over here again. I to the fourth, we're going to write this one out similar to the way we did the other problem. So this is I squared times I squared. All right, 2 plus 2 would give me the 4 that I need. So now this is -1 times -1 by simply substituting in the fact that we know that I squared equals -1. Well, -1 times -1 is +1. So I to the fourth is just 1. Now I want you to draw a big box around this because this is actually all we need, and I will show you why in just a second. But you need these values. So we know right through here that I is just going to be I, and that's equivalent to the square root of -1. But I is the big deal here. Then I squared is equal to -1, I cubed is equal to -I, and I to the fourth is 1. Now here's why this is the only thing we need. Let's look at something like I to the fifth power. Well, we can break that down as I to the fourth times I. But we know I to the fourth is just 1. So this is 1 times I, which is equal to I. Well, look up here, and that's back at the beginning. Well, let's look at I to the sixth. Well, this is I to the fourth times I squared. Well, that's 1 times I squared, and I squared is -1, so that's 1 times -1, which is just equal to -1. Well, if you look back up here, I squared -1. Well, if you want to take a little bit of thought process here, then you're going to realize I to the seventh is just I to the fourth times I cubed, which is -I. I to the eighth is going to be I to the fourth and I to the fourth, which is 1. So the basic idea is that every multiple of 4 gives us 1. So I to the fourth to any term, so I to the fourth, I to the eighth, I to the 12th, I to the 16th, all of that gives us 1. So if we can figure out how to get it in terms of I to the fourth, then that makes our life really easy. Easy way for us to remember what these are equivalent to. Simple little saying here. I won, I won. Kind of like you're excited after you win a football game or something. So I won, I won. I won, I won. Put your negatives in the middle. And then that tells you exactly what you need to know. I to the first is just I squared is -1. I to the third is -I. I to the fourth is 1. So I won. Put your negatives in the middle. So let's actually apply this. Let's look at a problem. Maybe I raised to the 92nd power. Okay? Well, I to the 92nd power. What I want you to do is I want you to take 92 and divide it by 4. Because remember, every multiple of 4 is just equivalent to 1. So 92 divided by 4, that is going to be equal to 23. All right, well, it goes in evenly, which means it is a multiple of 4. And since it's a multiple of 4, my answer is just 1. Because this is equivalent to I to the fourth to some other power. It's actually I to the fourth times 23. All right, so that's just equivalent to 1. So let's look at another one. Let's look at like I to the 45th power. All right, so what I want you to do is I want you to take the 45 and divide it by 4, because again, 4 is that magical number here. And you end up with 11.25. So it goes in 11 times evenly, and 0.25 is our decimal. I want you to X that 11 out. We're going to ignore it and act like it doesn't even exist at all. So 0.25, think about this as quarters. If I have 25 cents, how many quarters do I have? Well, I have 1/4. So that gives me I to the first power, and we know from I1 that is just I. So I is my solution. Let's look at a different one, maybe I to the 103. So what I want you to do is you're going to take 103, you're going to divide it by 4. That is equal to 25.75. Again, mark out the 25, you're left with 0.75. Well, that's like 75 cents, so that's like 3/4. So this is I cubed. Well, I cubed, I1 says that this is equivalent to negative I, so that is my solution. All right, 2 problems I would like for you to try on your own. Let's try I to the 25th power, and then maybe I to the 36th. Okay, hit pause, go ahead and try those 2. Okay, so we should have took 25, divided it by 4. It's always going to be by 4 every single time. This turns out to be 6.25. Ignore the 6. 25 cents, that's 1. It's 1/4, so I to the first, which is just I. And then over here we take 36, divide it by 4, and you get 9. There's no decimal left over, so that means this whole thing is just 1. So in terms of decimals, if you get a 0.25, that's I to the first, which is equivalent to I. If you get a 0.5, that's I to the second, because that's 50 cents, 2/4, which is negative 1. 0.75, 75 cents, 3/4, that means I to the third, which is negative I. And then if you do not get a decimal at all, that means, hey, this thing is I to the fourth. 4 goes into it evenly, so that just means 1. All right, hopefully that helped you figure out how to figure out I to the certain number of power. Go ahead and try your worksheet at this time.